Okay, here we are on trigonometry, section 3. So, again, a reminder not to use a calculator. A right triangle has a 60-degree angle. It has hypotenuse the square root of 2 divided by 3. Find the exact length of the other two sides using rules of special triangles. Okay, so we're going to draw our triangle. It has a angle of 60 degrees. I'm going to draw it right there. Okay, and it says the hypotenuse is square root of 2 divided by 3. Okay, so if I want to find like this side and this side, how do I do that? Well, I know that the ratio between the two red sides is 2 to 1. Okay, so I could take the hypotenuse, and which is square root of 2 divided by 3, and I could multiply by that times a half, and that would give me the length of the shorter red side. So that would be equivalent to 1 over 3 square root of 2. Okay, so that's x. Now, what about the orange sides? The orange sides, I know that the ratio between those is square root of 3. So I could take the x value, which is 1 over 3 square root of 2, and I could multiply it times square root of 3. And that'll give me the y value. So it'll be 1 over square root of 3 divided by square root of 2. And if I simplify that, it's going to be 1 over square root of 6. Okay? Sometimes math people don't like to put square roots in the bottom. And so, but I'm not a math person. I'm an engineer. So I don't mind it that much. But if you want to, you could rationalize it. Put a number on the bottom. Okay? Especially if you're going to be a mathematician, get into that habit. Okay? So this is your x value, and this is your y value. Okay, moving on to the next one. A farmer has a triangular field, ABC, as shown in the diagram. AB is 35 meters, BC is 80 meters, and BAC, which is this angle here, BAC is 105 degrees. They marked them all. Isn't that nice? D is the midpoint of BC. Okay, all right. Find the size of angle BCA. Oh, when you have an angle sign here, it's the same thing as saying the angle like C. Okay. All right. Let's find the size of the angle BCA. So the angle BCA is angle C. Okay. So how do we find this angle? Looks like we know here that those are a pair, those are an opposite pair, these are an opposite pair, and look at that, we know the green pair completely. If we know the green pair completely, we could use law of sines. And so we're going to say, hey, look, sine of 105 degrees divided by 80 is equal to the orange pair. And the orange pair, we don't know what the sine of the angle is, but we do know that the length of the opposite side is 35. So with this, now we can just use algebra and we can figure out that what sine of C is. So sine of C is equal to 35 divided by 80 times sine of 105 degrees, right? So now let's use the calculator. Oh, yeah, this part we need the calculator, right? 35 divided by 80, get 0.4375. Then we multiply times 105, or sine of 105 degrees. Sine of 105 degrees. Oh, and well, let's change the mode. We need to change the mode to degrees. So we're going to take 0.4375 times the sine of 105 degrees. And we get 0.423. Okay, so the sine is going to be 0.423. And so if we take the inverse sine of both sides, we know that the angle C is equal to 0.423 inverse sine. And that gives me 25 degrees. 25 degrees. Okay. So angle C is 25 degrees. Then we're going to go to the next part. It says to calculate the length of AD. What's AD? AD is from this point to point D. So it's that line there, okay? And we're going to find the length of AD. I'm going to give you a hint here. The hint says find the size of angle B. Angle B is here, okay? So we know that angle C now is 25 degrees. So how can we figure out angle B? Well, we can figure out angle B because the three angles of a triangle add up to 180, and right now we have two of the angles being 105 and 25. So let's take the angle B and we'll say it's 180 degrees minus 105 degrees and minus 25 degrees. And so basically that's going to be 50 degrees. Okay, so angle B turns out to be 50 degrees. Okay, so we know angle B is 50 degrees. How does that help us figure out the length of this red line AD? Well, we seem to have some important information here. One is that this side is 35. We also know that BD happens to be 40 because they told us that D bisects BC, right? So now we have an interesting combination. We have this combination. We have a side and an interior angle, and that is makes it possible to do law of cosines, and particularly if we want to know the opposite side. Okay, but basically, like whenever you have three pieces of information like this, and you can't use law of sines, and here it's obvious you can't use law of sines, then it's law of cosines. Okay, so law of cosines, the formula is this: a squared equals b squared plus c squared, and this you're definitely going to put it on your formula sheet, right? If you want to do extension, okay, cosine A. And now we're going to substitute the variables we want, which are the variables here. And so, like for example, we're going to say that this is angle A, okay, because we know it. It's 50 degrees. This is going to be let's say B, and this is going to be C, okay. And so here we're going to say that this angle A is 50 degrees, right? Cosine. And side BC is going to be 35 and 40. 35 and 40. And these are 35 squared and 40 squared, right? And A squared is unknown. Okay? A squared is obviously the red line, because that's the only side we don't know. Okay, and now we're going to use the calculator to do this too. So we're going to say b squared, which is 35 squared, plus, it's plus because it's c squared, it's not minus squared, plus 40 squared minus 35 times 40 times cosine 50. And that gives us 1,925. So that's a squared. And to find a, we do second square root of that number. And that gives us 43.9. Okay, so a is equal to 43.9. And that is the length of AD. Okay. Last of all, the farmer wants to feed his cow with only grass enclosed by the area ABD. Calculate the area of the grass. So ABD. So ABD is this triangle that we've been working with, right? It's this triangle here, the yellow triangle. So how do we figure out the area of this triangle? Remember that if you, again, know the purple 50 degrees, the purple 40, and the purple 35, you can use the formula A equals 1/2 AB sine C to calculate the area of the triangle without even using finding the base and the altitude or height. Okay, so that's cool. Let's do that. A equals 1/2 AB sine of C. The angle we know, sine of C, happens to be 50 degrees, right? And the two adjacent sides are 40 and 35. Is that right? Okay, and we can never forget to multiply by 1/2. A lot of people forget to do that. Okay? So, if we do that, it's going to be 1/2 times 40 times 30 times sine 50. Let's do sine 50 first. Sine 50 is that, 0.766. Then we're going to multiply that times 1/2 times 40, which is 20, and multiply that times 35. And the answer is 536. Okay, let's move on to augmented matrices. Okay, matrices. Okay, use augmented matrices to solve the following system of equations. Remember that augmented matrices, what you do is you take the coefficients from, oh, look what I did. I made a boo-boo. This should be A, right? Okay. To use augmented matrices, the first thing you're going to do is you're going to copy all the coefficients into an augmented matrix. The reason why it's called an augmented matrix is in addition to the 2x2 part, which is the coefficients, we also augment an initial row, which is the results here on the right side of the equal sign. And we represent the equal sign by putting this vertical line here. Okay? Now, once you have it set up like this, remember you can do any kind of row operations to eliminate one of the coefficient elements. And the way we're going to do that is we're going to multiply rows by number, and then we add it or subtract it from other rows. And eventually what we want is to get an identity matrix on the left side. And when we do that, we've solved it. Okay? So if you need to review, go ahead and go back to the unit with matrices and review this. Okay? So first what we're going to do is we're going to multiply the bottom one times 3, and then we're going to add it to the top one. So we're going to have negative 3. On the bottom, we're going to have negative 3, 36, and negative 96. Okay? And then we're going to add it to the top. So we're going to get 0 and 34 and negative 96 plus 28. That would be about negative 66. Except maybe a couple more, so it'd be like negative 68. Is that right? I think it is. So our new first row would be 0, 34, and negative 68. And then our bottom row would still be negative 1, 12, and negative 32. Okay? And then the top row, you can see we can simplify it by dividing the whole top row by 34. If we divide the whole top row by 34, then we're going to end up with 0, 1, and negative 68 divided by 34 happens to be negative 2, right? And then in the bottom, we still have negative 1, 12, negative 32. Now we can easily get rid of the 12 in the bottom by multiplying the top one by negative 12 and then adding to the bottom. So if we multiply the top one by negative 12 and then add it, we are going to do we're going to have negative 12 here, and we're going to have 24 here. And so we'll have 0, 1, negative 2, and when we're going to add negative 12 to positive 12, we get 0. We add positive 24 to negative 38, we get negative 8, right? So here we're going to put negative 8. And then we can switch these two rows between each other in order to end up with a identity matrix like we planned to. Okay, and then we get this. Alright, and basically what this is saying is x, or the first variable, which happens to be a is equal to negative 8, and b is equal to negative 2. Okay, so that's our solution. For b, it says that we should find the inverse of the following matrix. The first step to finding the inverse to a matrix is to find the determinant. Okay, so the determinant for a 2x2 matrix, you can write this in your formula sheet if you remember, is AD minus BC. A being this one, B being this one, C being this one, and D being this one. Okay, so AD would be 2 times negative 5, which would be negative 10. And then BC would be negative 3 times 4, which would be negative 12. So subtract that. So that would actually be negative 10 plus 12. And so our determinant is 2. Okay? If the determinant is 2, that means that we're going to multiply by 1 over 2, and we're going to find the inverse of b. And the way we're going to do that is first we're going to put 1 over the determinant here, and then we're going to multiply times a variation of this matrix, which is we're going to switch the first and the fourth elements with each other, and then we're going to take the negatives of the other elements like that. Okay? And then we can multiply 1/2 times each one of these, and so maybe it's not going to be such a nice multiplication. -5/2, 3/2, and then the bottom is going to be -2 and 1. Okay, so this is our inverse matrix for B. It says to explain and demonstrate proving a result is indeed the inverse matrix of B. Make sure you explain it using the concept of the identity matrix. Okay, so basically, if we can show that the B times its inverse is equal to I, and B inverse times B is also equal to I, then we know that they're matrices. Okay, so let's try to do that. So we're going to have the original matrix 2, -3, 4, -5, and we're going to multiply that times this, which is -2.5, 1.5, -2, and 1. Okay, if we multiply those together, we're going to get, this is going to be kind of a pain. So we'll have this times this, okay, so it'll be -5 plus 6, so it's 1. So that worked. Then we're going to do this times this. So that'll be 2 times 1.5, which is 3. -3 times 1 is -3, so we get 0. Hey, it's working out so far. Okay, now we're going to do 4 -5 and this. So it'll be 4 times -2.5, which is -10. -5 times -2, which is +10. Hey, that worked out too. Last of all, we're going to do 4 -5 times 1.51, and that'll give us 6 minus 5, which gives us 1. And it worked. Okay, so that's wasn't as bad as I thought it was going to be. Let's shrink this down a little bit, and then we're going to do the opposite direction. Okay, so the opposite direction would be -2.5, 1.5, -2, 1, and we're going to multiply that times 2, -3, 4, -5. And let's see. So we're going to multiply first -2.5, 1.5 times 2, 4, and so that will give me -5 plus 6, which is 1. And then we're going to do -2.5, 1.5 times -3, -5. So that would be -3 times -2.5 would be positive 7.5. And then 1.5 times -5 would be -7.5. And so when you add those two together, you get 0. Then we're going to do -2, 1 times 2, 4. So that -2 times 2 is -4. 1 times 4 is +4. And you add them together, you get 0. Last of all, we're going to do -2, 1 times -3, -5. -2 times -3 is +6. 1 times -5 is -5. So 6 minus 5 is 1. And so it worked also. Okay, so we've proven that these two matrices are really inverses of each other. Okay, and that's it for now.